Welcome, 6th grade. Today we're going to talk about triangles. We've been talking about line segments and all those other items. Hopefully you enjoyed your Quizlets yesterday. Today we're going to work on different things. Two angles whose sum is 90. Hopefully you said complementary. What are two angles whose sum is 180? Hopefully you said supplementary. Remember S for supplementary, S for straight angle. A part of a line between 2 points is called a line segment. Alright? And two lines that intersect and make a 90 are perpendicular. Alright. Good job. So today we learned to classify triangles and solve problems involving angles and side angle measures of triangles. Sounds like a lot, but it's not too much. You do have 6 vocab words. Remember, it's all about vocab. The big positive is there's another Quizlet coming where you can study and learn up on those for the next 5 lessons. Acute triangle, obtuse triangle, right triangle, congruent, line segment, scalene, isosceles, and equilateral. These all focus on naming a triangle based on an angle, or all of the angles. These focus on the sides. So angles, sides. And what I'm going to do for a lot of them is ask for both names. Congruent, we know, means same. Line segment means a portion between 2 dots. So we can use those. A triangle is a closed figure with 3 line segments and 3 angles. You probably knew that. Triangles can be classified by the measures of their angles. That's what we're going to look at. An acute triangle has only acute angles. Acute angles are less than 90. Every angle in the triangle must be less than 90. It is in this case. Obtuse triangles. They will have one and only one obtuse angle. They can't have more than one because a triangle can only have 180 degrees. And if you're more than 90, 2 of them added together is more than 180. And a right triangle, remember this guy right here. That square means a right angle. And a right triangle will only have one right angle. Now you know how to figure out the angle way a triangle is named. To decide whether a triangle is acute, obtuse, or right, you need to know the measure of its angles. So the sum of the measure of the angles in a triangle are 180 degrees. You see, they ripped off the corner, they put them up there, and when they put them that way, they make a straight line. We know a straight line is 180 degrees. Now, by knowing the sum of the measures of the angles in a triangle, you can find angles you don't know, such as this. Sarah designed this triangular trophy. The measure of angle E is 38. And the measure of angle F is 52. But she forgot to write down D. What a travesty. But I know if I add 38, and I add 52, and I add, I don't know what D is, but if I add that in there, it'll be 180. Oh yeah. Well, can't I add these two together? That makes 60, 90 degrees for those two. Plus D equals 180. You probably already see, Grayson, that D is going to be 90 degrees. But if you don't see it, I want D all by itself. Minus 90. Inverse operations, remember that? Minus 90. D equals 90 degrees. Then 90 plus 90, that makes 180. And we have everything we need. I just had to add these two together, subtract them from 180, and I get what's left, which is D. All right, that's exactly what they did. Imagine. So with this one, hopefully you can see what we need. Now with this one, E is 22, F is 22. And we don't know what D is. Hopefully you see when I add 22 plus a 22 plus D, which I don't know what it is, it'll equal, I heard somebody say it, 180. 44 plus D equals 180, and we subtract our 44, we subtract our 44, and D ends up equaling 136 degrees. All right, I hope I did my math right. That would be 50. Yes, I think I did. Now, the other question I have to ask you is, what kind of triangle is this? Acute, obtuse, right. Obtuse. And we'll see their math. My math checked out. All right, we're good to go. Now you can use what you know about vertical, adjacent, complementary, and supplementary angles to find the measure of missing angles. Whoa, that's a lot. Vertical, they're congruent, and they're across from each other. Adjacent, side by side. They share a ray. Complementary and supplementary, hey, we did those in the review, you should know. Okay, so we have a triangle that's been busted up to pieces. We have to think. Use the diagram to find the measure of each indicated angle. QTR. QTR. We want to know that angle right there. Now hopefully you can see that QTS makes a straight line. So this is 68. How do I figure out what this is? 180 minus 68. That gives us 112 degrees. 112 degrees. Well, that does look obtuse. So we can see triangle QTR is an obtuse triangle. Now, we've got QTR. They did that by taking 180 minus 68 because we had a straight angle. Let's see what they ask about next. Now they want to know QRT. Angle, remember angle, it's different. QRT. I've got to do a few things here. I don't know. I know this whole thing is 90, but I only want to know this part right here. I don't have a good way of figuring that out, except if I can find this one out. Do any of you see? It's kind of like what we did before. 68 plus 55 plus, I don't know, I'll make it X, equals 180. Okay? 55, 68, that's 13, 1, 6, that's 123. Plus X equals 180. I subtract, inverse operations, I subtract. That means 57 degrees is X. Now 57 degrees, that's a whole wonderful thing. But I didn't want to know that angle. I wanted to know that guy. So, I have a 90-degree angle divided into 2. So 57 minus, 57 plus, the angle I don't know, let's call it Y, equals 90. Subtract 57, subtract 57, Y equals 33. I bet this guy equals 33. Two-step problem. It wasn't very easy. We had to find out this guy so we could find out this guy. Good thing all you girls out there were thinking. All right. Let's see what they talk about. So, 180 minus 68 plus 55. Hey, that's what we did. That got them 57 for this guy. Hey, that's what we got. Then we take 90 minus 57. And they got 33. We got it right. Well done, ladies and gentlemen. Oh, now they change things. They want to know M-N-O. M-N-O. This guy. He looks like he's going to be obtuse, but how obtuse? We take simply 180. We subtract 44. And we get 136 degrees. That's that guy right there. They did the same thing and got 136. Now they want to know M-O-N. I bet, if we add these two together, which would be 104, we're going to take 180, because all three of these add to 180, and we're going to find out that that's 76 degrees. This one's 76 degrees. Hold it. We want to know this guy right here. Oh yeah, 90 minus the 76, 14. We get our 14 degrees. Hopefully you can see that. If not, you can read what they did, see what they did, and know, hey, it's kind of the same as what we did. Looking that over, checking that over, you'll see what you can see. Sorry about the delay there. The phone gave me a crazy message. All right, now we skip to other things. So we had those first three types of triangles. Now we have three more. This time we look at sides. All right, we have a scalene triangle. Scalene means like this. Not one single side is the same. They're all different, just like all of you. All right, isosceles. Isosceles, you can see this line and that line. That means this line segment is equal to or congruent to that line segment. Isosceles triangles have two congruent sides. And then we see an equilateral. The equilateral, you see 1, 2, 3 lines. All three of the sides are congruent. Just a buzzkill. Two congruent sides means two congruent angles. Three congruent sides means three congruent angles. Just if you're looking to get ahead a little bit. So now, let's classify the triangle. The sum of the lengths of the sides is 19.5. So if I add this, and I add this, and I add this, I get 19.5. So 6 plus 5 is 0.6 plus 5. E plus, we don't know, C equals 19.5. Oh, those two make 13. Plus C equals 19.5. Minus 13. Minus 13. Don't forget your decimals and whatnot and so forth. All right. This guy's 6.5. All the sides are the same. It's a equilateral triangle. Oh, good job, ladies and gentlemen. Now, this side. We see two sides are the same, so we can automatically know it's an isosceles triangle. But if we have 7.2 plus 7.2 plus D, it says the perimeter is 15.6. So that's 14.4 plus D equals 15.6. Minus 14.4 minus 14.4. Then D equals 2 here, 1 here, 1.2. And yes, one side is different, the other two sides are the same. That's an isosceles triangle. Checking out my math just to make sure I'm not losing it. 2.2. Oh, 6 minus 4 is 2. My apologies. And hopefully you have enough to know what you're doing today. Bye, 6th grade. Sorry, Addie with a Y, that I did not include you on the first share.